Okay, IBAASL2. Today we're still talking more and more derivatives. It seems like we're just getting all these tools in our toolbox for finding derivatives. So far we got the quotient rule, the product rule, the chain rule, plus the power rule. Today we're going to talk about some sort of specialty functions and what their derivatives are. I'm going to set a link somewhere in our Canvas so you guys can see some explanations on Desmos as to why these things are true. But I thought we'd start with just a palette of some derivatives here. If you have an exponential function f of x equals e to the x, then if this is what it starts like, the derivative is just itself, which is kind of a funny one, but it makes sense if you kind of think of a Superman curve, an exponential curve of it taking off, and you think about the slopes of this, it actually does make sense that it is itself. So that one's kind of a freebie in my mind, that whenever you see e to the x, the derivative is just e to the x. The next one is the natural log of x. Remember, natural log is the same thing as log base e of x. It's just written ln of x. That one, the derivative is 1 over x. And once again, if you're very curious about why these things are true, you can check it out on Desmos. The book also makes a point of giving you guys this one, that if f of x equals e to the kx, where k is just a constant, then the derivative is k e to the kx. But I think this one you can kind of figure out just by doing a chain rule, because you can think of this as the inside function, the k of x, and then the derivative is just k. So it's the derivative of the outside with the inside the same times the derivative of the inside. The derivative of the inside is just k. Okay, let's do a bunch of examples. F of x equals 5e to the x plus 2 ln x. Well, this is pretty straightforward, that you just break it up into two separate parts and take the derivative of each part. So the 5 can just chill out in front, and the derivative of 5e to the x is just 5e to the x. Remember, e to the x is the freebie that always just stays the same. Now, ln of x is going to be 1 over x, so we can just write this as 2 over x. Is that the way they put it? Make sure I'm on the right track here. Yeah, we're good. 2 ln x, so they just do, 2 over x. I was just making sure they didn't do 2 times 1 over x or something, but 2 over 1 times 1 over x is 2 over x. So that one's actually done. It's pretty straightforward. This one is also straightforward if you just think about it in terms of a chain rule. That the derivative, so the chain rule is you take the derivative of the outside with the inside the same, but the derivative of the outside e to the x is just e to the x, so that's e to the 2x, but then you have to multiply it with the derivative of the inside. So this is, 2e to the 2x. Now, slightly more involved problem, e to the x times ln of x. This is a product rule, which is first d second plus second d first. So h prime of x is first, and then d second, the derivative of ln x is 1 over x, plus second d first, which the derivative of e to the x is just e to the x. So for this one, I think you can do a little bit of cleanup. We'll just smush the first two things together here. So this becomes e to the x over x. And then the other part you can't really do anything with. I would just call it e to the x ln x. Yeah, that's it. Next example is a quotient rule, which is low d high minus high d low over low squared. So low d high, but the derivative of the high is just itself, e to the x is e to the x, minus high d low, and the d low, keep it on the d low, guys, is 1 over x, and then all over low squared. So we get ln x squared. Now, how much cleanup do we need to do here, book? Not a ton, really. They factor out the e to the x from both these terms, so it looks like this, but I don't know if that's absolutely necessary. So the e to the x would be on the outside, and then you get ln x minus 1 over x, and this is all over ln x squared. I don't know if that's absolutely necessary to factor out the e, but you could. Sure, go for it. Help yourself. Okay, you guys, the derivative of sine of x. Let's start with a quick review about what sine of x is. Sine of x from 0 to 2 pi is a mountain and a valley. It starts at 0, goes up the mountain, back down, into the valley, back up and out. Now, sine of x and cosine of x, I always get confused about which one is which for the derivatives because they're very similar. So whenever I get confused, I just think about the slope machines of these curves. This slope right here starts off with a slope of 1. So if I start to draw the derivative, it starts at 1. But then as it goes up the hill, the slopes get lower and lower until eventually they hit a slope of 0 up here at the top, a turning point. Which means that at pi over 2, we have a slope of 0. So it goes, slopes start off at 1 and then go down to 0. Then the slopes turn negative from pi over 2 to pi, and then they turn negative. And then at 3 pi over 2, so like here if I was to draw these in, they're like negative, 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 negative. But then here, you have a slope of 0 again. So this comes back and crosses at 3 pi over 2. So it looks something like this. Then the slopes turn positive again and go all the way up until you have a slope of 1 at pi over 2. So it comes back up the mountain. Now, you guys, if I was to zoom out, what does that orange curve look like? Oh my gosh, that's right. It looks like cosine. So if y equals sine of x, then the derivative is cosine of x. It's very similar if you look at the slopes with the derivative of cosine, that the slopes start off with 0, and then they go negative, negative, negative until they hit 0 at pi. So if they start at 0, and then they come back at pi, that means that this goes and comes back, and then at this turning point right here, they're going to hit 0 again. So it looks like this. That looks a lot like a cosine curve, except it's upside down, or sorry, it looks a lot like a sine curve. Upside down sine of x, which is just negative sine of x. So if y equals cosine of x, then y prime equals negative sine of x. So 2 more big derivative rules. Sine of x is cosine of x derivative, and the derivative of cosine of x is negative sine of x. See how many examples I can do before my next class comes in. Okay, the first one. You just split them up, do them separately. Sine of x is cosine of x, and cosine of x is negative sine of x. So you get negative 3 times negative sine of x. So this equals 2 cosine x plus 3 sine x. The next one is a product rule, which is first d second. So first d second, oh sorry, I forgot an x in there. So first d second, cosine is negative sine of x, plus second d first. So when you have sine times sine, that's sine squared. So this is negative sine squared x plus cosine squared x. Was that supposed to be an x? With this one, I think that was supposed to be an x. Nice x, Jolly. This is a chain rule because you have to think of this as sine of x to the 1/2. So when we take the derivative, maybe it was supposed to be a t. Maybe I'm messing things up here. G of x, oh well. G of x, derivative of the outside with the inside the same. So derivative of sine is cosine. So that's cosine with the inside the same times the derivative of the inside. So the derivative of the inside would be 1/2 x to the negative 1/2. Oh boy, a lot of cleanup. Okay, let's see. I'll bring the 1/2 out in front, then I'll keep the cosine root x, we'll put it just over 1 for fun, and then the x to the negative 1/2 becomes 1 over x to the positive 1/2. So this is cosine square root of x, and everything on the bottom would just be 2 square root of x. Please remember that these square roots do not cancel out because this one is really glued together with the cosine. You cannot do that. All right, last example. Remember that cosine squared is the same thing as cosine of x quantity squared. So if you're going to find the derivative, well, there's two different ways you could do it. You could think of it as cosine times cosine and do a product rule, or you can think of this whole thing as a chain rule where cosine is the inside. Let's do chain rule. Chain rule would be derivative of the outside with the inside intact. So if you take the derivative of the outside, the 2 comes out front, and then inside stays the same. But then you have to multiply times the derivative of the inside. Derivative of cosine is negative sine of x. So this is negative 2. I'll put the sign first just because people seem to do that. So it's negative 2 sine x cosine x. All right, you guys, that's all I have for you today. We, of course, are going to be practicing all this stuff lots. This is just kind of a big day to put lots more tools on the table. The next couple of days will be just applying and doing lots more problems with our big new toolbox. All right, good luck.